Hey guys, welcome back. I'm actually here to film a screencast for a fellow teacher. They had asked me to try to do a basic explanation of finding electron configurations for elements in the Lanthanide and actinide series. So that's what I'm going to try to do in this video. That way other teachers can use it as well, or students. Um, really, it depends upon the layout of the periodic table that you're using, uh, of how the difficulty can grow. If you notice on my periodic table that I give my students in class, notice how around the lanthanide and actinide series, it's a newer version of the periodic table where it actually shows a space of insertion here. A lot of the older periodic tables, what they would do is they would actually have a space here using these two here, and then having them offset and things like that. You know, showing the LA and the AC up here, I should say, showing the LA and AC up here, and all of a sudden it jumps back up with the YB and the NO and the LU and the LR being reversed. Well, I love this version of my periodic table that I use on my website for my students because it's so easily laid out. For once, the F block on this one actually starts with the lanthanide and actinide series. On the other versions, the earlier versions of the periodic table, they so conveniently didn't have it that way. They actually had the LA and the AC up here with either star markings or whatnot. Then they would jump down and you would see CE and TH right here, and then at the end here we would finally see the LU and the LR. And that's just, kind of crazy to me why they always did that. But anyway, uh, so I honestly suggest that if you have one of these old periodic tables on your wall or in your classroom or in the book, I would print them off this version of the periodic table. It's more user friendly. But anyway, after you finally decide which periodic table you are going to use, you need to make sure that your students understand how each block starts. For example, this is the S block up here, and I'll go ahead and write an S up here, that way we can see it. This S block actually starts with a 1S right here, and then the next row would start your 2S, and then this one would start your 3S, and then the next one would be your 4S. I've explained this in earlier videos, but not in this detail, so if you want to, just keep watching this one, or look at, you may also refer back to the other ones. But anyway, it goes 1S, 2S, 3S, 4S, 5S, 6S, and finally down here would be 7S. And it's good that they know that this is where they start. So like this hydrogen, its location would be 1S1. The location of this helium would be 1S2. Lithium would be 2S1. Beryllium would be 2S2. That's just the locations. Sodium would be 3S1 and magnesium 3S2, so on and so on, all the way down to francium, where francium's location would be 7S1 and radium would be 7S2. But anyway, after that, once they understand location, just like in Battleship, instead of sinking their battleship, we're going to sink their element. But anyway, maybe make a Battleship game out of it or whatnot for them, so they can actually kind of try to enjoy this. But anyway, over here will be our P block. Now our P block starts out, instead of with a 1P, it starts with a 2P. Okay, so this is 2P. This aluminum will be 3P. Then you would have 4P. I'm sorry I'm writing in the periodic table, but this is the only place I can fit it in. 5P. Down here would be 6P. And then this one would begin the 7P. Okay. Now, explain to them that boron's location would be 2p1, carbon 2p2, fluorine would be 2p5 because it's the 1, 2, 3, 4. It's the fifth element in that row, so that would be 2p5. And explain all the way down to UUO, which would be 7p6. And then bismuth would be 6p1, 2, 3, so be 6p3. Anyway, once they have those under under wraps and they get that, then explain to them that the D block, notice how the S block started with one S and the P block started with two P. Well, ask a leading question. What do you think this block is going to start with? If this block started with a 1, this one started with 2, guess what this one's going to start with? Well, yes, you're right. This starts with a 3, but a 3 what? Well, remember, this block, these 10 elements in this row, starts with a D. So this is your D block. And then make sure that they understand that this is 3D. Sometimes you can tell them, hey, remember, this has to start with a 3 here because look at that column number. So that will help them remember what the row starts with. And that would be a 3D. Of course, explain to them their exceptions. And here's your 4D, and then this one will be the beginning of your 5D, and then the last one there would be the beginning of your 6D. Okay, make sure that they understand that scandium starts to 3D1, and iron would be 3D 1, 2, 3, 4, 5, 6, 3D6. Now you do want to go over the exceptions with them. In high school, I go over the exceptions with high school students. Also with college students, I go over the exceptions because they have to know them. But you can start with the most basic ones if you want to. Now finally, the one that was in question was the Lanthanide series. And I really think that in order to get the Lanthanide series down and understood, that the students need to know this layout. And they also need to understand that the F block, which is the Lanthanide and actinide series, this F block starts down here with a 4 because see, the first one started with a 1, the P block started with a 2, the D block started with 3. So just remind them that this Lanthanide series starts with 4F, and tell them to pay attention to the atomic number, which is the number of protons, which is 57, 58. Tell them to pay attention that the 4F would have to come before the 5D, and the same thing here. This would have to be 4F, and this down here would have to be 5F. Okay. Anyway, show them that, and if they feel that that's not good enough, then if they've got this newer version, then they can come up here, just squeeze in that this is going to be their 4F1. That was a horrible F, but anyway, a 4F1 through F14, and that way they can remember that the F block has to come before that D block there. And same thing here, having them write in that this was 5F1 through 5F14. They cannot just forget about them because if they have something in the F block, they have to be able to label it, right? Okay, but anyway, just reiterate that and explain that clearly. Now, a lot of times, I like using, it's kind of cheating, but it's a memory gimmick. They always call them an Aufbau tree, or it's using the Aufbau principle. And let me show you that. Okay, those help high school students a lot, and even some college students that they're just trying to get in and out of chemistry. So let me show you the Aufbau tree. Okay, here's one right here already laid out for us. Notice how it shows the progression of the electron configurations, their energy levels, and how you're supposed to move through. Let's just do one at random here, okay? Let's say that we were going to try to do, say, P. Well, I don't even know what PM is off the top of my head. Let's look for something that's kind of cool stuff. So let me look. Let's choose. Yeah, let's do uranium. Okay, we're going to do this one for our example. Okay, uranium 92. Well, notice that they need to understand location. The location of this uranium is 5F, 5F1, 5F2, 5F3, 5F4. Now let's look at the Aufbau tree. Find your 5F. Well, I see our 5F. Our 5F is actually right there. Okay, so here is our 5F. Okay, and we know the location of our 5F. Let's go back and look at it real quick. The location of our 5F for uranium is 5F1, 5F2, 5F3, 5F4, 5F4. So what they can do is they can keep in the back of their mind, well, I know my location. My location is 5F4. Okay. Now what they'll do is they'll start up here and they'll follow their arrows. Okay, so notice that they pass up one S. Now remember, if you pass up an S, that S gets a 2 because it's full. That P, if you pass it up, it gets a 6. The D, if you pass it up, gets a 10. And for every F you pass up, it gets a 14. Okay. Now, let's go ahead and try to get uranium. Okay. I'll probably need a lot of room. There's my U. Sorry, I'm just using a mouse. To get to this 5F, you have to pass up 1S, so we write down 1S. Now remember, we're passing it, so it gets a 1S2. Okay, once you go all the way down to the head of the arrow, go back to the tail. It's like head of tail in physics. Okay, so you go back down, and this is 2S2, so you write 2S2. Now after that, you completed that, got to the arrowhead, start the tail again. Here comes our first P. This is a 2P6. Okay, and then you keep going down, and you run into a 3S2. 3S2. Keep going, and you run into a 3P. Well, that's a 3P6. 3P6. Just keep going. 4S2. 4S2. Okay, let's do another one. 3D10. So let's write it in. 3D10. What's after our 3D10? 4P6. 4P6. Okay, what's after our 4P6? 5S2. So we write in 5S2. Yes, I know I'm skipping down here. 5S2. And then what? Well, we go to 4D. Well, what was a D get? 10. So that'll be 4D 10. Okay. Then a 5P6. 5P6. Next, 6S2. 6S2. Okay, after 6S2, got to the head of that arrow, go all the way back to the next one. That'll be 4F14. So write that down. 4F14. Then 5D10. Okay. 6P6. Told you this one's going to be long. Okay. 7S2. Start on another line. 7S2. Then finally, where we're trying to end up at, 5F. Now remember, we're doing uranium, and uranium, our location, was 4. So believe it or not, that funny little puppet guy that does the puppets, Jeff Dunham, his Ahmed the Dead Terrorist, comes in handy. Location, location, location. It's important, so make sure the students understand location. Now remember, if you're doing the noble gas electron configuration of this, you can just remind the students that for uranium, their noble gases are in this column here, the P6 column. So you can just tell them, just pick up from your last noble gas that you passed, which I honestly don't know what that is off the top of my head, so I need to go back and look. The last noble gas that we would pass before was Rn, radium. That's 86. I know it wouldn't be the 118 because I hadn't got there yet, but it's the 86, so that's Rn. So let's go back and actually, there was the message I got. Go back to the Aufbau tree and in brackets write down your noble gas, which ours was Rn. Okay, and then close your bracket, and then pick up from there the 7s2, and then finally the 5f4. 5f4. So anyway, I hope this one is a little bit better at explaining. I know that students get frustrated with these, but show them the Aufbau tree, it makes it a whole lot more easier on the students to get it. But I love having my students to run across the periodic table, but remember that some students do get frustrated with it running across the periodic table. But if you can, find a newer version just like this one. If you want this one, it's on my website, print it off. And I hope this explanation is a little bit better than uh, possibly what you may have heard in the past from me or for some other teachers. So anyway, I hope it was helpful. You have a great day.